Welcome, traveler. You found the slumbering cosmos. Tonight is a long night, and I have gathered something special for it. 10 impossible things. 10 places in the universe where the numbers stop making sense. Where a galaxy is too old, or a star is older than time should allow. Where the rain is made of diamonds, or a shape appears that has no business existing. 10 small mysteries that real scientists with real telescopes have run into and have not fully explained. But here's my promise to you, and I mean it, not one of these mysteries is frightening. Every single one of them has been sitting quietly in the universe for billions of years, doing no harm to anyone, waiting patiently to be understood. They're not threats. They are puzzles. And there is nothing in the world more restful than a good puzzle you are allowed to leave unsolved until morning. So this is going to be a long, slow walk. 10 stops. You do not need to reach the end. Most travelers won't. They'll fall asleep somewhere around the third or fourth impossible thing. And that is exactly what this is for. If you make it all the way to the 10th, that's fine too. Either way, you cannot fail tonight. There is no way to do this wrong. So before we begin, let's set the day down. All of it. The things that went well and the things that didn't. The conversation you keep replaying. The small list of tomorrow's worries, already forming at the edge of your mind. You don't have to solve any of it tonight. None of it needs you awake. Whatever is unfinished will wait for you, patiently, and it will still be there in the morning, and you'll meet it then, rested. Not now. Now is for drifting. Let yourself go heavy. Feel the mattress take the full weight of you, your back, your legs, the backs of your hands. Let your shoulders slide down, away from your ears. Let your jaw come unclenched, your tongue rest soft in your mouth. The small muscles around your eyes go loose and still. Feel the day drain slowly down through your body and out through the soles of your feet and away into the dark where it can't reach you. And let your breathing slow, all on its own. You don't have to force it. Just notice it. The quiet rise, the slower fall. And let each breath out be a little longer than the one before, the way the tide goes out, unhurried, certain in no rush to return. Take one slow breath in and let it go completely. Let's begin with the first impossible thing. The first impossible thing is a set of galaxies that should not exist. To understand why, you have to know one strange and beautiful fact about telescopes. They are time machines. Light takes time to travel, so when you look far away, you are also looking far back. The sun you see is 8 minutes old. The nearest star is 4 years in the past. And the most distant galaxies are billions of years gone. You're seeing them not as they are, but as they were when their light first set out toward an Earth that did not yet exist. So in 2022, when the James Webb Space Telescope opened its golden eye and looked as far as it possibly could, it was looking back nearly to the beginning, to a time only a few 100 million years after the Big Bang. The universe then was supposed to be a quiet nursery. A few small, dim, scrappy proto-galaxies just beginning to gather themselves. Faint smudges. That was the prediction. Instead, Webb found galaxies that were huge. Bright, massive, mature galaxies full of stars, already grown up, at a time when the universe was still a toddler. Some of them appear to hold as many stars as our own Milky Way, which took more than 13 billion years to build. And they had done it somehow in a few hundred million. It was as though you looked at a photograph from the first week of someone's life and found a fully grown adult already standing there. Astronomers, being careful people, went quiet and then went to work. Maybe the galaxies only look that massive. Maybe black holes at their centers are making them shine brighter than their true weight. Maybe the early universe made stars faster and more efficiently than we ever imagined. Maybe our measurements of distance are subtly off. The mystery is not solved. It is being gently taken apart, one careful observation at a time. But tonight, you don't need the answer. Tonight, I just want you to hold the picture. Out there at the very edge of what we can see, at the very beginning of what there is, whole cities of stars were already burning, warm and bright and impossibly early. And they have been shining patiently ever since, waiting all this time for a telescope and for you to finally notice them. And let me tell you the names softly, because the names are lovely and they help nothing, and that is exactly why I want you to have them. One of these early galaxies is called Maisie's Galaxy, named by an astronomer after his daughter on her birthday. Another carries a string of letters and numbers so long and so gentle that reciting it is very nearly a lullaby. These faint red smudges, each one a city of 100 billion suns, each one impossibly old, each one carrying a small human name given to it across 13 billion years of distance. Picture the light itself on its journey. It left those galaxies when the universe was new, and it has been falling toward us ever since, through the long dark, past everything, patient beyond patience, crossing an expanding ocean of space for 13 billion years, only to end its journey inside a golden telescope a million miles from Earth on a quiet morning, so that a few tired scientists could lean toward a screen and go quiet. All that travel, all that time, for one small moment of being seen. The universe grew up faster than we thought. There's no harm in that. Rest now. There are 9 more. The second impossible thing is a star that appears to be older than the universe itself. Its name is HD 140283, but astronomers gave it a better one. They call it the Methuselah star, after the oldest man in the old stories. And it sits quietly only a couple of hundred light years from Earth, close enough in cosmic terms to be a neighbor. Here is the trouble with it. When astronomers measured everything they could about this star, its brightness, its temperature, the almost complete absence of heavy elements in it, which is the mark of something very, very old. The numbers came back saying it was around 16 billion years old. But the universe is only 13.8 billion years old. A star cannot be older than the universe that made it. That is not a mystery. That is a contradiction. It is like meeting someone who was born before their own grandparents. Something somewhere had to be wrong. And this is the part one love, the part that should let you breathe easier, not harder. The scientists did not panic. They did not tear down the Big Bang. They simply said, we have probably measured something slightly wrong, and let's find out what. They refined the star's distance, using more precise instruments. They improved their models of how such an ancient star burns. And with each improvement, the star's age crept downward to around 14 billion years, and then with generous room for error, comfortably under the age of the universe after all. The contradiction dissolved, not with a battle, but with patience. The Methuselah star is still ancient, very nearly as old as time itself, one of the oldest things you could ever point a telescope at. It formed in the young universe, long before the sun, long before the earth, and it is still there tonight, still shining, having outlived very nearly everything. Think of it, a single star quietly burning for 13.5 billion years. So old it briefly seemed to break time, and it has been keeping its steady light the entire while, asking nothing, needing nothing, simply persisting. If something that old can go on so calmly, so can you for one ordinary night. Think about what this old star has quietly witnessed. It was already ancient when the gas cloud that would become our sun had not yet begun to gather. It was already ancient when the earth formed, and when the first life stirred in earth's warm, shallow seas, and when the first fish crawled on a land, and when the dinosaurs came and went, and when the first human being looked up at the night sky and wondered. Through every one of those enormous chapters, the Methuselah star simply went on burning at the same soft, steady pace, changing so slowly that across the entire history of life on Earth, it has barely aged at all. It asks for nothing. It has no audience for most of its long life. Only in the last century did any eye on Earth even know it was there. And yet it keeps its light perfectly, faithfully, whether or not anyone is watching. A small, patient furnace at the edge of our neighborhood, older than almost everything, calm as still water. There is a particular peace in old things that have made their peace with time. The Methuselah star does not hurry toward its ending, and it does not mourn its beginning. It simply is, tonight, as it has been for 13.5 billion years, and as it will be for a good while yet. Let the Methuselah star keep its long watch. Drift on to the third impossible thing. The third impossible thing is a place where it rains diamonds. Far out in the cold half of the solar system lie the two ice giants, Neptune, deep and blue, and Uranus, pale and tilted on its side. They are strange, quiet worlds, so far from the sun that noon there is little more than a bright dusk. And beneath their calm outer clouds, something extraordinary is thought to be happening, slowly, endlessly, all the way down. These planets are rich in methane, the same simple molecule that gives them their soft blue color. Methane is made of carbon and hydrogen, and as you sink into these worlds, the pressure climbs to unimaginable weights, thousands upon thousands of times the pressure at Earth's surface, and the temperature rises into the thousands of degrees. Under those conditions, deep inside the planet, the methane is crushed and torn apart. The hydrogen is stripped away, and the carbon that is left behind is squeezed and squeezed until it does the only thing carbon can do under that kind of pressure. It crystallizes. It becomes diamond. And these diamonds, freshly formed in the dark, are heavier than the fluid around them. So they do what heavy things do. They begin ever so slowly to fall, down through thousands of kilometers of dense, hot interior, a gentle, endless precipitation of diamonds, drifting down toward the core, where they may gather into a vast, glittering layer that no eye will ever see. Scientists have even briefly made this happen on Earth. In laboratories, they took plastic, ordinary carbon, and hydrogen, and hit it with shock waves to recreate the pressures inside Neptune. And for the smallest fraction of a second, tiny diamonds bloomed in the sample, exactly as the theory promised. So it is real. Somewhere above you, right now, on two blue worlds most people never think about, diamonds are forming in the dark and falling like slow rain, and have been falling for 4.5 billion years, and will keep falling long after everyone who ever wondered about them is asleep. And let yourself sink slowly into what that would actually be like to descend through one of these worlds. You would pass first through the high, cold, blue-green haze, calm and clear, then into thickening clouds, softer and warmer, the light fading from twilight to a deep, dim glow, then deeper, where the air becomes a thick, warm fluid, neither quite gas nor quite liquid, and the pressure wraps around you like a heavy blanket, gentle and enormous. And somewhere in that warm, dark, blue depth, all around you, unseen, the diamonds would be forming and beginning their long, slow fall, sparkling for no one, drifting down through the dark at the speed of settling dust, a snowfall of jewels in a place without a single eye to see it. There is something wonderful in that the universe makes treasure in places no one will ever collect it. That beauty happens whether or not anyone is watching. It doesn't need an audience. Neither do you tonight. You can simply rest while somewhere far away it quietly rains diamonds. On to the fourth impossible thing. The fourth impossible thing is a perfect shape drawn in the clouds of a giant planet by nothing at all. At the North Pole of Saturn, there is a hexagon, not roughly six-sided, not hexagon-ish, a genuine six-sided geometric hexagon with straight edges and sharp corners, wider than two Earths placed side by side, cut into the golden clouds around the planet's pole. It looks deliberate. It looks drawn. It looks like something with a ruler and a plan came along and pressed a shape into the sky. When a Voyager spacecraft first glimpsed it in the 1980s, and then when the Cassini spacecraft studied it in detail decades later, the reaction was more or less universal disbelief. Nature makes spheres and spirals and rough circles. Nature does not, as a rule, make crisp hexagons the size of planets. And yet, there it was, and there it still is, a stable, spinning, six-sided river of cloud, unchanged across the 30 years we have been watching it. So what draws it? Not a hand, not a mind, just moving fluid. Physicists have recreated the shape in the laboratory, using nothing but a spinning cylinder of liquid. When you rotate a fluid at the right speed and set another current flowing within it at a different speed, the boundary between them cannot stay a smooth circle. It buckles in a regular, repeating way, and depending on the exact speeds, it settles into a stable pattern of waves that close into a triangle or a square or a pentagon or a hexagon. Order arising on its own from nothing but motion and time. That is the quiet lesson of Saturn's hexagon, and I think it is a gentle one to fall asleep to. The most geometric, most deliberate-looking shape in the entire solar system was made by no one. It was not designed. It simply emerged because that is what those particular flows at those particular speeds naturally become. Beauty and order do not always require an architect. Sometimes they are just what happens when a system is left alone, spinning quietly for a very long time. And it is not only beautiful, it is patient, and it is huge, and it is slow. Each side of the hexagon is longer than the diameter of the Earth. The whole shape rotates once with the planet's day, about every 10.5 hours, a leisurely turning of a structure large enough to swallow 4 Earths in a row. Within its walls, winds move at hundreds of kilometers an hour, and yet from a distance the whole thing looks utterly serene. A slow golden pinwheel, holding its geometry across decade after decade, unbothered, unhurried, unchanging. The Cassini spacecraft, in its final years, watched the hexagon shift color with Saturn's long seasons, from a soft blue to a warm gold as sunlight slowly returned to the northern pole over the years. It photographed the great shape from directly above, and the image looks less like a photograph of a planet than like something drawn in a dream. A perfect six-sided rose of cloud, turning silently in the dark at the top of a world 9 times wider than our own. No one holds its corners in place. No one drew it. No one maintains it. It simply keeps its shape on its own because that is what the flow becomes. Order sustaining itself effortlessly for as long as the planet turns. The hexagon is turning up there right now, holding its impossible corners, needing no one to maintain them. Let it turn. Drift onto the 5th impossible thing. The 5th impossible thing is that something enormous is pulling us, and we cannot see what it is. Everything in the universe is moving. The Earth goes around the sun. The sun goes around the center of the Milky Way. The Milky Way itself is falling through space, along with its whole neighborhood of galaxies, at a tremendous speed. Hundreds of kilometers every second. Right now, you, in your bed, are being carried across the cosmos faster than you could ever feel. And when astronomers carefully measured which way we are being carried, they found something strange. We are not drifting randomly. We are falling. All of us, the Milky Way and Andromeda, and thousands of nearby galaxies, toward a single point in the sky, in the direction of the constellations Norma and Centaurus. Something over there is pulling. Something with the gravitational weight of tens of thousands of galaxies. They named it, for lack of a better word, the Great Attractor. And here is why it earns its place among the impossible things. We cannot see it. It sits in a region of the sky that is blocked from our vantage point by the crowded, dusty, brilliant band of our own Milky Way, a zone astronomers call, rather poetically, the zone of avoidance. Our own galaxy stands directly between us and the thing that is pulling us, like a bright hand held up in front of our eyes. For decades, we could feel the pull and measure its strength and not lay eyes on its cause. Slowly, using X-rays and radio waves that can pierce the dust, we have begun to see through the veil. It seems the Great Attractor is a colossal supercluster of galaxies, and beyond it, something larger still, an almost unimaginable concentration of mass called the Shapley supercluster, drawing everything gently toward it across hundreds of millions of light years. But notice what the pull actually is. It is not violent. It is not sudden. It is the softest possible tug, spread across distances so vast that it will never gather us in. The universe is expanding faster than the attractor can reel us home. We are simply leaning, ever so slightly, toward a bright far country we will never reach, and being carried, all together, in good company, through the dark. And I want you to feel how gentle this really is, because the word attractor sounds like grabbing, and it is nothing like grabbing. Gravity does not reach out and seize. It only bends the shape of space a little, and everything nearby simply rolls slowly along the new curve, the way a marble rolls toward the low point of a wide, soft bowl. There is no jerk, no pull you could ever feel. The earth beneath you is falling toward the Great Attractor at this very moment. And so is your bed, and so are you. And the falling is so smooth and so shared that it feels exactly like perfect stillness. That is the strange grace of it. The whole local group of galaxies, the Milky Way, Andromeda, and dozens of smaller companions, moves together as one, in the same direction, at the same time, held in each other's company as they drift. No galaxy is left behind. No galaxy falls alone. They travel the way a flock of birds travels, or a slow current of leaves on a wide river, each one carried by the same gentle pull, all of them going the same way through the dark, together. You're being pulled somewhere too tonight, towards sleep. Let it carry you. You don't have to see where you're going. Just lean into it, the way whole galaxies do without fear, onto the sixth impossible thing. The sixth impossible thing is the opposite of a crowd. It is the emptiest place we have ever found. In the direction of the constellation Boötes, the herdsman, there is a hole in the universe. Astronomers call it the Boötes Void, and sometimes, more grandly, the Great Nothing. It is a roughly spherical region of space nearly 330 million light-years across, and inside that enormous volume, there is almost nothing at all. To feel how strange that is, you have to understand how the universe is normally arranged. Galaxies are social. They gather in groups and clusters and long glowing filaments, strung together in a vast cosmic web, like foam, or like the pattern of soap bubbles pressed together. In a region the size of the Boötes Void, you would ordinarily expect to find perhaps 2,000 galaxies, crowded and clustered and shining. The Boötes Void contains about 60 galaxies scattered across 300 million light-years of darkness, so far apart that if you lived in one of them, you might not know the others existed. As one astronomer famously put it, if the Milky Way had formed in the center of the Boötes Void, we would not have known there were other galaxies until well into the 20th century. We would have thought our single spiral of stars was the entire universe. We would have been profoundly, cosmically alone and not even known it. For a while, the void seemed impossible, too big, too empty, a flaw in a smooth universe. But we have come to understand it gently. The cosmos is not a uniform soup. It is a web, and every web has holes. Small voids, over billions of years, drifted together and merged into larger ones. The way small soap bubbles merge into a big one, their thin walls combining. The Boötes Void is simply one of the grandest of these empty chambers. Not a wound in the universe, but natural room in its architecture. Vast and silent and calm. And if you could stand on a world inside that void, on some planet circling one of those 60 scattered galaxies, the night sky above you would be almost perfectly velvet black. No band of Milky Way arching overhead. No scattering of bright neighbors. Just a deep, still, uninterrupted dark, with a few of the faintest smudges near the edge of sight, so dim you might take them for a trick of the eye. It will be the most peaceful night sky in all of creation. Nothing to crowd it, nothing to hurry it, only distance and quiet and the slow turning of your own small world beneath an almost empty heaven. We tend to fear emptiness down here where every moment is crowded. But the Boötes Void is not lonely in the way we imagine loneliness. It is simply spacious. It is the universe at its most unhurried, its most open, its most restful. A vast, calm room where a few quiet lights drift, each one content, each one whole, none of them needing the others to be exactly what it is. I find the great nothing strangely comforting, and I hope you will too. Emptiness, it turns out, is not an error. It is part of the design. The universe is mostly space, mostly silence, mostly rest, and the few bright galaxies drifting through the Boötes Void are not lonely and failing. They are simply quiet and far apart and perfectly at peace in all that room. You have room like that tonight. Let the quiet be spacious, not empty. Drift on to the seventh impossible thing. The seventh impossible thing came from another star, passed through our solar system, and left again before we could get proper look. In the autumn of 2017, a telescope in Hawaii caught something faint moving very fast against the stars. When astronomers traced its path, they realized, with a jolt, that it had not come from anywhere in our solar system. Its trajectory was wrong. Too steep, too fast, bent in a way that meant it had fallen in from the space between the stars, swung once around our sun, and was already on its way back out, never to return. It was the first object we had ever seen from another star system. A visitor. The astronomers in Hawaii named it Oumuamua, a Hawaiian word meaning, roughly, a scout or a messenger from the distant past, reaching out. And it was deeply strange. It was small, only a few hundred meters long, and it was tumbling, and as it tumbled, its brightness changed so dramatically that it had to be a bizarre shape, extremely long and thin, like a cosmic cigar, or perhaps a flat disk, unlike any asteroid we had ever seen. Stranger still, as it left, it sped up slightly, given a tiny extra push that comets get from venting gas, except that Oumuamua showed no visible tail, no cloud of gas at all. It accelerated gently for no reason we could clearly see. There was briefly wild speculation. Could it be artificial? A fragment of alien technology, a derelict light sail drifting between the stars? A few serious scientists even asked the question aloud, but most came to a calmer conclusion. Oumuamua was most likely a shard of something natural and wonderful, perhaps a splinter of frozen nitrogen from the surface of a Pluto-like world around another star, or a fluffy fractal of cosmic dust, exotic materials that could vent invisibly and explain the gentle push. We will never know for certain. It is gone now, tumbling back out into the dark, growing fainter every night, already far beyond our reach. We had a few weeks with a traveler from another star, and then we let it go. And think of the journey it was on long before it ever met us. Oumuamua had almost certainly been traveling alone through the empty space between the stars for hundreds of millions of years, perhaps longer. It was torn from its home system in some ancient event we will never know, and flung out into the dark, and then it simply drifted in absolute silence through a cold so complete and a distance so vast that our sun, for most of that voyage, was only one more anonymous star among thousands. For all those ages, nothing happened to it. Nothing touched it. It just fell and fell and fell through the night between the stars. And then, for a few short weeks, it passed through one small pool of warmth and light, our solar system. And for the first and only time in its endless journey, it was seen and named and wondered about by beings on a small blue world. And then it was gone again, back into the long dark, to fall for another 100 million years toward the next star, which it may never truly reach. And maybe that is the loveliest part. For 4.5 billion years, our solar system kept to itself. And then just once in our lifetimes, a small cold messenger fell in from the deep, brushed past our sun, and continued on its ancient way, carrying whatever secrets it holds towards some other star will not reach for millions of years. It did not need anything from us. It simply passed through the light and returned to the dark calm the whole way. Everything passes through, and everything is allowed to move on. Let the visitor go. Drift toward the eighth impossible thing. The eighth impossible thing is a kind of star that will still be shining long after the universe as we know it has ended. When we picture stars, we usually picture the dramatic ones. Great blue giants that burn furiously and die young in brilliant explosions. Stars like our sun, which will swell and glow and gently expire over 10 billion years. These are the stars that fill the picture books, but they are not the most common stars in the universe. Not even close. The most common stars are the small, cool, dim red ones. Red dwarfs. Stars perhaps 1/10 the mass of our sun, glowing a faint ember red, so dim that not a single one of them is visible to the naked eye from Earth, though they make up 3/4 of all the stars there are. The sky is full of them. It is mostly made of them, and you have never seen one. And here is their impossible gift. Because they are so small and so frugal, they burn their fuel with almost unbelievable patience. Our sun will live for 10 billion years. A small red dwarf will live for trillions. Not billions, trillions. Some of them will still be quietly burning 10 trillion years from now, 1,000 times the entire current age of the universe. By then, all the bright stars will be long dead. Star formation will have ceased. The great galaxies will have gone dark. And still, scattered through the cooling dark, the little red dwarfs will glow on. The last campfires in an enormous, quiet night, tended by no one, going out one by one over spans of time the mind simply cannot hold. There is a red dwarf just 4 light years away, Proxima Centauri, the closest star to our sun. It is one of these. Small, dim, and almost eternal. When our sun has swollen and died and faded to a cold cinder, Proxima will not even have reached its middle age. It will keep on glowing faithfully for trillions of years, warming its own small planets, long after the story of the sun is over. And there's a reason they last so long, and it is a gentle one. A big, bright star burns hot because it is under enormous pressure, racing through its fuel in a kind of magnificent hurry, and it pays for that brilliance with a short life. A red dwarf is different. It is small enough and cool enough that it burns its fuel with extraordinary thrift. And this is the loveliest part. It slowly stirs itself, mixing its fuel through its whole body over the ages, so that it can use very nearly every last drop, down to almost nothing. It wastes nothing. It rushes nowhere. And so it lasts 1,000 times longer than the show-offs, and more. If you could watch one across its whole life, you would see almost no drama at all. No swelling into a giant. No violent death. Just a small, steady, ember-red glow held at the same soft brightness for trillions of years, warming its quiet planets, keeping its long and patient watch over a universe that grows darker and calmer around it with every passing age. The last light in the cosmos will not be a brilliant one. It will be a small red star, glowing low, having outlasted absolutely everything, simply because it never once tried to hurry. I find something deeply peaceful in the red dwarfs. The universe's longest-lived things are not its brightest or its most violent. They are its smallest, its calmest, its most modest, the ones that never rush, never flare, never draw attention, and simply endure gently, almost forever. There's a kind of wisdom in burning low and lasting long. Burn low tonight. Last the night gently. Drift onto the ninth impossible thing. The ninth impossible thing is a cold spot in the oldest light of the universe. A mark that may just possibly be a bruise from touching another universe entirely. You may remember from other nights, the oldest light there is the cosmic microwave background, the afterglow of the Big Bang, a faint, even warmth that fills the whole sky in every direction. When we map that light across the heavens, it is astonishingly smooth, the same temperature to within tiny fractions of a degree everywhere you look. A soft, uniform glow, left over from a universe's first bright moment. But in the direction of the constellation Eridanus, there's a patch that is colder than it should be. Noticeably, stubbornly colder over a huge span of sky. Astronomers call it simply the cold spot. And for years, it has resisted easy explanation. The leading gentle answer is that the cold spot is the fingerprint of an enormous super void, a vast, underpopulated region of space, even grander than the Boötes Void, lying between us and that patch of ancient light. As the old light passed through all that emptiness on its long journey to us, it lost a tiny bit of energy climbing out and arrived just slightly cooler, a shadow cast by a great nothing. That is very likely all it is, and it is beautiful enough on its own. But there is another idea, and I share it not because it is likely, but because it is one of the most wonderful thoughts in all of science, and it is a lovely thing to hold as you drift off. A few physicists have wondered whether the cold spot could be something far stranger, a mark left on our universe by a soft collision with another universe. If our cosmos is only one bubble among countless others in a much larger foam, an idea some serious theories genuinely allow. Then long ago, in the first instant, our bubble might have brushed, ever so gently, against a neighboring one, and the cold spot might be the faint, permanent bruise where the two universes once touched. Almost certainly, it is only a super void. That is where the careful evidence leans. But no one can yet completely rule out the other thing. And so, tonight, you are allowed to look up at that one cold patch of the ancient sky and wonder, softly, sleepily, with no need to decide, whether it might be the one place where our universe once leaned against another and came away marked like two soap bubbles that touched in the dark and drifted apart. And I love that the honest scientists hold both possibilities at once, gently, without needing to force the matter. They lean toward the super void because that is where the careful evidence points. But they do not slam the door on the stranger idea because the evidence does not quite let them. Not yet. They simply keep both thoughts on the shelf, side by side, and go on measuring patiently, year after year, content to not yet know. That is a rare and beautiful kind of calm. To sit with a question that large and not be troubled by it. To be able to say, it is probably the shadow of a great emptiness, and it might just possibly be the one place our universe once brushed against another. And either way, I can sleep tonight. The cold spot has been sitting quietly in the sky since the beginning of the universe, harming nothing, waiting without impatience to be understood. It can wait a little longer. It can wait until you wake. Whatever it is, it has done us no harm in 13 billion years. Let be a mystery. Drift onto the 10th and last impossible thing. The 10th impossible thing is the end of everything, and I have saved it for last because it is the gentlest of them all. Everything we have visited tonight, the two old galaxies, the ancient star, the raining diamonds, the hexagon, the great pull, the great emptiness, the visitor, the patient red dwarfs, the cold and distant bruise, all of it is part of a universe that is slowly, quietly changing, expanding, cooling, growing older like everything does. And if you follow that change all the way to its end, far, far into the future, you arrive at a fate physicists call, rather beautifully, the heat death of the universe. It sounds ominous. It is not. Let me tell you how it actually goes. First, over the coming billions of years, the bright stars burn out and are not replaced for the gas to make new ones grows thin. The great blue giants go first, then stars like our sun, until at last only the patient red dwarfs remain, glowing low. Then, over trillions of years, even they cool and fade to embers, and the galaxies go dark, and the sky, if anyone were left to see it, grows quiet and black. Then the timescales grow so long that ordinary words fail. Over spans of time with more zeros than there are atoms in your body, the dead stars drift apart, and the galaxies dissolve, and even the great black holes at their centers, which we visited on another night, slowly evaporate into the faintest imaginable glow and are gone. And the universe becomes, at the very last, an endless, thin, cold, calm sea of dim light and drifting particles spread out across unthinkable distance, cooling forever toward a temperature just barely above the coldest cold there is. And here's why I find it not sad, but profoundly restful. The end of the universe is not a bang, and not a fire, and not a crushing. It is a settling. It is everything at last coming to rest. It is the cosmos exhaling one final, endless, quiet breath, and then holding still. After all the burning and colliding and pulling and racing, after all that effort across all those ages, the universe finally gets to do what you are doing right now. It gets to stop. It gets to be still. It gets to rest. And that ending is so unimaginably far away that it has no claim on you tonight. Between now and then lie spans of time next to which your whole life and all of human history and the entire age of the earth are less than a single breath. The universe is all the time there could ever be. And so tonight, do you? There is no hurry. There is nowhere you have to be. There is nothing left undone that cannot wait. And notice, if you like, one last tender thing about it. All the striving of the cosmos, the galaxies pulling on galaxies, the stars igniting and burning and dying, the diamonds falling, the hexagon turning, the visitor rushing through, the great voids yawning open. All of that effort, all of that motion is only a passing phase. A middle chapter. The universe was calm and dark and quiet before the first star ever lit, and it will be calm and dark and quiet again, long after the last one fades. The stillness is not the interruption. The stillness is the natural state, the beginning and the end, the wide quiet within which all the burning briefly happens. So when you rest tonight, you are not stepping out of the universe's true nature. You're stepping into it. You are doing, in miniature, exactly what the whole cosmos is slowly, patiently moving toward: a settling, a cooling, a coming to rest, a long quiet after a long day. There is nothing more natural in all of existence than to grow still. Everything comes to rest in the end. Even the stars, even the galaxies, even the universe itself. There is no shame in it and nothing to fear. It is simply what everything does at last when a long day is over. So that is all 10. 10 impossible things gathered up for one long night. Galaxies that grew up too fast, and a star that seemed older than time. Diamonds falling as rain, and a perfect hexagon drawn by no one. A great and gentle pull we cannot see, and a great and gentle emptiness 300 million light years wide. A visitor from another star, passing through and moving on. Small red embers that will outlast almost everything. A cold mark in the ancient sky that might be the touch of another universe. And at the very end of all things, a quiet settling into rest. Not one of them is a threat. Every one of them has been out there the whole time, patient, harmless, waiting, and they will all still be there tomorrow and the night after and long, long after that. You do not have to understand them. Scientists themselves do not fully understand them, and they sleep soundly enough. The not knowing is not a burden. It is just the part of the sky that is still dark, still waiting for morning. Let all go now. The questions will keep. They have kept for billions of years. They will certainly keep until you wake. Feel the weight of yourself in the bed, the pillow beneath your head, the whole patient earth beneath that, turning slowly through the night, carrying you gently around the sun, the way it always has, the way it always will. The impossible things are keeping their places. The galaxies are drifting. The diamonds are falling. The little red stars are burning low and will burn low for trillions of years, and none of it needs you awake to continue. And from here, the music will simply go on for a while, soft and slow, with no more words to follow, no more places you need to travel. You have already arrived everywhere you needed to go tonight. There is nothing left to do but rest. If you're still a little awake, you can let the quiet sound carry you the rest of the way down at your own pace and your own time. And if you're already mostly gone, then these last few words are only for the small part of you still listening. And to that part one, say, simply, it is all right to let go now. You are safe. You are held. The night will keep. So close your eyes now, if they're not already closed. Let them stay closed. There is nothing more to see tonight that morning cannot show you better. Breathe in slowly and out even more slowly. And again, and let each breath be a little quieter than the last. The universe is full of impossible things, and it holds every one of them without effort, without worry, without ever needing to solve them tonight. The two old galaxies, and the ancient star, and the falling diamonds, and all the rest. It carries them all gently and asks nothing of them but to be. Let it hold you the same way, effortlessly, completely, asking nothing of you but to rest. The cosmos is slumbering, and so are you. Good night, traveler. Sleep among the impossible things.